Hello, everyone. So I decided that since I had the opportunity with these two motors, I thought I would do this for fun and for learning purposes. Um, these are the two motors, specifically the stator portions, of the ILG 10P blowers that I have. Now, the one on the left here is single phase. The one on the right is three phase. So we can I'll turn this around so we can see the tags of both. I'll start with a single phase. So you can see it's 1/3 horsepower, 50-60 cycles, single phase, 3,400 RPM. Uh, Now this one is 115 and 230. You can see the amperages there. We got 3.2 amps and 1.6. So now I will switch over to the three phase. Again, 1/3 horsepower. This one just says 60 cycles, but um, you could just run it at a lower frequency and it'll run a slower RPM. But we have three phase and 3,400 RPM again. This one, however, you can see they stamped 208 on the side, but it's a 220 or 440 motor. So 1.1 amps for the low voltage, and here's the 440. We got 0.65. This is a 6-lead motor, and it's either wired in delta or star, depending on which voltage configuration you want to work with. And you can see the single phase has a capacitor mounted on the back, and the three phase, of course, does not. I'm not sure, but I think that may be an original sticker put on by ILG when it left the factory. Um, so, this is what the windings look like. You can see here that these are 2-pole motors. Now, for the single phase, it's really easy to see that because we've got one coil up here and one coil down here. Those are your actual run windings, so that's your 2 poles. And then 90 degrees out, we have this one, and that is on the inside here, and those are the start windings. So you have a pole and a pole there. Really, it's like you could kind of, if you split the motor this way, you can look at it as you've got your run winding and you've got your start winding, and think of it as it's like pulling it around. So that is the single phase. Now, the three phase is a little bit more tricky to, if you just looked at this without knowing any information about the motor, it would be kind of difficult to determine what RPM this turns, how many poles it has, etc., because there's actually 18 coils here, and all 18 coils are exactly the same. They're all identical to each other. So at first you would think, well, okay, it's three phase, so is this a 6-pole motor? You got 1, 2, 3. Well, no, it's not. How they've done this is lap wound, but it is what's called a 3-layer lap wound motor. So if you look carefully, you can see some insulation paper right here. It goes right down in between here, and then you can see some more right in here, and you can see some more right in here. So what that's doing is that's actually the phase paper, phase insulation. That's separating a barrier between each phase. And you can see, here's the phase paper. You got 1, 2, 3 coils, and then another layer of phase paper. 1, 2, focus, 3 coils, and another layer of phase paper, and it goes around like that. So what I decided to do is measure and take note of the winding arrangements here, and I have made just a kind of quick diagram showing this. So you can see your single phase, you've got the start windings are this teal color here that goes around, and you can see that they're concentric wound, and this one has 4 separate parts of the coil, and then the run winding actually has 5 that go around. And these are different gauges as well. So the start winding is a little bit thinner wire. It's 24 gauge. the nominal figure that I'm getting with the enamel coating is about 22 thousandths of an inch. So I looked it up, and the closest thing I could find for that with enameled wire is 24 gauge. And then I'm getting about 27 thousandths on the run windings, and that gives you, with the enamel coating, you're looking at 22 gauge there. So I don't know the number of turns, but I do know the resistance in each of these coils. So I'm getting a resistance of 7.1 ohms across both of these run winding coils. And this is measuring just each coil. Now, the start winding, you can't individually measure because they're bonded together in the motor, but I just took the resistance of the entire start winding circuit and then divided it by 2. So it was about 25 ohms. So 12.5 ohms per coil for the start winding. So that is the single phase motor. Now, we'll look at the three-phase motor. The three-phase has the 18 coils, as I said, which go all the way around. And you can see here the different colors. So this green is actually, I have it as phase C. I mean, it's just literally just a distinguish between the different phases. But you can see every other slot is where the coil starts, and it has a coil span of 9. So wherever you start here, this is the starting coil, starting slot rather, and you would count 1, 2, 3, 4, 5, 6, 7, 8, and 9, and that is where the coil spans from there to there. And then each coil skips a slot. So we've got a coil here, and then we have another coil here. And you can see the 3 that are the same color, these are the 3 all in the same phase. So this one, and this one are all linked together, and that's one pole of this phase. The other pole is down here. And then we've got over here, this is the next phase, and it's opposite pole. So you got these 2 poles. And then you have the third phase here and here. And you can see how those are arranged. So basically, every revolution, this motor's going A, B, C, A, B, C, A, B, C, going around like that. But of course, it's switching off polarity. So say we're talking a North Pole magnetic field, so it'll be North Phase A, North Phase B, North Phase C, and then, of course, the opposite poles, they would have been South Pole at the same time, and then they switch. So every cycle, that's switching. And for this, I determined I could measure, it's a 6-lead motor, so each one of these coil sets for each phase has 2 leads coming out. So phase A, 34 ohms, obviously 3-phase, they should all be identical, and they were. They're all 34 ohms. Now, if I divide that by, there's 6 coils per phase. You've got 3 up here, 3 down here, 3 over there, 3 over there, and so on. So each coil has a resistance. If I just do division, that's all I did. I can't measure it, but looking at about 5 2/3 ohms per coil. So I'm still learning about this as far as how to switch from a single phase to a 3-phase winding, because I'm planning on rewinding one of my ILGs that I have. It's a single phase type Q fan, and I'm actually planning to rewind it as a 3-phase. So I'm trying to learn what exactly I will need to do in order to figure out the proper wire size, number of turns, resistance between the different ones. Now, obviously, it's tricky because I still don't know the number of turns here. So I can't give a ratio of number of turns from this one to this one. I have no idea, but I do know the resistance. So I may be able to get some kind of a close guess here. But either way, I thought that this would be interesting to some of you if you're trying to dig more into these motors. Well, here's a little close-up, and you get to see inside. Now, these are the exact same core. They are a 36-slot stator core. They're the same thickness, the same depth, the slots, everything's the same here, except this one has been painted at some point. But the only difference here between this and this is just the windings, which of course we've got single phase versus three phase. So I thought it was pretty interesting to look at this. So if you have any questions or if there's anything that you would like to see or know specifications that I did not mention, please don't hesitate to ask. And if you haven't done so already, please like and subscribe and have a fantastic day.